Hi, in this video we'll start working with NumPy arrays. Arrays are sequences, like strings and lists, but are specially designed to work well for managing large amounts of data. Let's start by looking at one way to create a NumPy array. We'll make a variable called numbers and assign the value of np.arange10 to that, and then we'll print it out. This is an array with the numbers 0 through 9, excluding 10. As usual, we can look at its length with len. We can index it, and we can slice it. With arrays, we can modify values, so we can change the value of numbers at index 0 to 20, and then have a look at that. You can see the 0 has been replaced with a 20. The main limitation is that we cannot insert or remove values from the array. It's going to remain the same size. We created the numbers array with np.arange, which can use two numbers to generate the range between them. np.arange 100 to 150 will give us all the values between 100 and 150, again not including 150 itself. Use three numbers to use a different step size. If we do np.arange in the same range, but use a step size of 2, now we have a much shorter array that goes 100, 102, 104, and so on. A similar function is np.linspace, but with linspace, the third number is the desired length of the array. So if we go from 100 to 150, we can specifically say we want 100 values, and it'll figure out how big to make the step size in order to make it go from 100 to 150 in exactly 100 values. Linspace is different than most other ranges in that it is inclusive of its upper bound by default. Here, when we specify linspace has an upper bound of 150, there's actually an element in here that's 150. If you do arange, it's not going to actually have the 150 in its range. We can create arrays from existing Python lists. If we create a list as a quick series of numbers, we can then convert that to an array by doing np.array and then putting the list in parentheses. We can also load arrays from text files, which is what we'll often be doing for large data sets. In this folder, I have a simple data set, fib.txt, and this is just one entry per line in a text file. We can load this into a NumPy array by doing np.loadText, and then putting the file name in quotes. In this case, it was fib.txt. You can also save NumPy arrays using np.saveText. First you give it the name of the output file. We'll save it to number.txt, and then you give it the name of the array you want to save, numbers. And even though it doesn't display any output here, if we now look at the directory, we can see number.txt has popped up, and it has the values we initially set it to. We can start with empty arrays of a certain size by doing np.zeros and then putting in the size that we want. This is an array of 10 zeros. np.ones is the same idea, but instead the array is full of ones. We can use NumPy's random number generation to create an array of random numbers. This is np.random.rand. There's two dots. And in here we again put the number of values that we want. These values are going to be uniformly distributed between 0 and 1. If we specifically want integers, we can use np.random.randint. And then the two values inside the parentheses are the lower bound and the upper bound, with the third value being the number. If you can pick the right function to create an array, it can give you a head start on further processing it.